Right. Okay, so title of the talk is Architecting for Mobile Apps. As we all know, what architecture is basically a structure or design or blueprint of a plan, maybe in terms of building. Um, but in software, we would say it's the various design decisions we take in our project, how we are going to build this project, how other people will interact with other developers will interact with the software, how they are going to be able to join us in writing code. Which now leads us to talk about clean architecture. I'm sure most of you might have heard about clean architecture from like the internet and other places, probably from Bob C. Martin, or also popularly known as Uncle Bob, which is somehow like the main speaker on clean architecture from his books. He actually wrote one called Clean Code. So clean architecture is not really an architectural pattern. It's more of a design. It's more of like a design philosophy on how we are supposed to structure our programs, which basically tries to tell us about the onion model where every dependency in your project is actually a layer. And why we talk about these layers is so we are able to separate the concerns in our projects. Clean architecture has tried to actually be the embodiment of solid principles. Now, we will hear about solid principles a lot, especially maybe in code interviews, computer science theory, and especially if most of you have come from Mandela as well. Mandela is very forward about solid principles. They talk about it a lot, and solid principles are basically ways in which we should write better software, ways we should write better apps. Solid principle, like the first one, we have a single responsibility, which basically talks about every class should actually do one thing. It should be specific. We shouldn't have classes which are going to do more than one thing. If you have a user class, it should just be for the user. It shouldn't delve into doing other things, as well as your methods or your functions. They should actually do one thing. It makes it easier when you look at a program and you can see that your methods do one thing. It's easier to debug, as well. It's easier to build up on top of that. Then you have the open close principle, which says classes should be open to extension, but they should be closed to modifications. This actually helps us build tight systems that help us to avoid unnecessary bugs much later. So if you are going to build software, you should know that any class you are trying to create should be easy for other people to extend the functionalities, but modifying existing functionalities should not occur, because if someone extends your class and later on someone goes to modify these things, the method or the function might not actually perform as it was supposed to because it's been modified. Instead, these functionalities should be extended. Then list call substitution, I'll just go over the solid principles very quickly. List call substitution just tells us an interface should be able to we should be able to switch a child interface with its parent. So if I also have a class of user and I have a subclass of profile that extends from user, I should be able to use profile instead of user, and the program should still behave exactly the way it was expected to. Um, things joined in. Let me see if. All right. Okay. So in Kotlin and Java, we know of our classes like the list class and the array list class, and the collections class. So when we talk of list class substitution, we should be able to, if we have a class of list, we should be able to take a subclass of list and replace that list class. Like an array list is a subclass of list, and it should work exactly the same way, even though the array list has more functions, but it should still work the same way. That's basically what the list call substitution tells us. Then interface segregation. almost similar, but just says classes who are going to extend from an interface should only extend from interfaces and not adding more methods to an interface that are not necessary for the classes. Instead, you would need to create a new interface that probably builds off the old one. And dependency inversion is builds off from the previous one, which just says we should build on top of abstractions, not the details. So that's just a rundown of the solid principles. So why we talk about solid principles is because clean architecture itself is an embodiment of solid principles, but it's a way for us to think about our apps or our softwares and architect towards that. So the clean architecture just helps us embody these principles in what we build. Now, when we talk about architecture, especially in Android, people confuse it for MVVM, MVP, MVI, MVC. And don't get me wrong, these are actually also architectures, but they are architectural patterns for the front end layer, but not the complete software stack. Uh, the MVV, MVP, and etc. patterns are actually just for the presentation model. But when we talk about clean architecture itself, we are trying to talk about the complete software stack and not just the presentation model. Most times when we look at these architectural patterns, we see people talk about architecture. All they talk about is the presentation layer, forgetting that the presentation layer or the presentation module actually feeds off of other architectural patterns within the software. After all, architecture, whether you think about it or not, it would always be there in your code, because all decisions you make while building your software is an architecture. Even though you don't take the time to actually do that, it would have its own innate architecture. So most times it's best for us to actually sit down and plan these things. I'm sure a lot of us are already conversant with MVVM and MVP, right? Right, so common architecture patterns we have is microkernel, microservices, and layered. I might not go into these much, but just to give you an insight of an overall architecture stack, most of the very common ones you would see in Android are the microkernel, which is like plugins, where every model you build into your app would function as a plugin, like you're attaching something new into the app. Like if I can give an example of Facebook, Facebook kind of functions like microkernel architecture, where you see them introduce new things into the app, but that function like separate entities. Uh, Now, within these other architectural patterns, they can still be based off clean architecture, because clean architecture is not really talking about how you plan your own app architecture, but it's just trying to tell you how to embody solid principles into these things you do. Maybe later on when we go through one of the code projects, it will be easier to really understand this. Then for microservices, we hear microservices a lot, but usually in backend architectures, but it's actually present in Android as well, where every feature is built separately and treated as its own separate app. So you could have like a multi-bundled Android app, and each feature there would be its own app or separate. I think recently when Android started talking about dynamic modules, microservices architecture is kind of like making that easier. Then layered is like, I think, the one that's always used everywhere, where each module builds off the previous one, and the flow of data is actually linear. So and anytime you have questions, just let me know. I'll just go back. So here we have some little principles about clean architecture. Application code is separated into layers. Layers should follow a strict dependency rule. We shouldn't have our layers leaking dependencies or trying to move off from another layer that they are not supposed to touch. Like next one, you can see here, high level modules should not depend on low level modules, and both should depend on abstractions. See, when we build our softwares on top of abstractions and not details, it helps us create something kind of like a contract. Like our interfaces act like contracts, and if we build on top of interfaces and not details, you can easily swap out these dependencies or implementation patterns. You can easily swap them out much later without having any problems with modifying the whole software itself, because all you're doing is building on top of the abstractions and not the details. Yeah, abstractions should not depend on details, but the details should depend on abstractions. When you're about to write your code, you need to plan out these abstractions. You need to plan out the interfaces. What would this class be doing? What are its functions? You write it down and you create that to be your interface. And any other class that's going to use these functions should actually be using the interface itself, but not the details. The details always need to be separate from the interface. So here we have a module of what clean architecture tries to tell us to do. The innermost layer, which is the domain layer, is actually the highest level. So you can see that it now moves forward into the use cases and the data. These two now depend on the domain module. Then the presentation layer and the framework now depend on the use case itself. So you can see the presentation doesn't directly just go and talk to the domain itself, but it allows itself to build off use cases, and the use cases does not talk to the presentation layer. The use cases does not know anything about the presentation layer. It it talks to the domain layer, and the domain layer is usually what we call the business logic, the whole brain of the program. So the domain layer is what's going to contain all the abstractions that the other packages are going to build up on. And we have a dependency flow versus the data flow. On the left, you can see that the presentation builds off the domain, data builds off of the domain. But in terms of how the data flows itself, you can see that the presentation makes a request down to the domain. And this moves down to the data layer, which would now return the request with the respective response and flow back up. So it's kind of like a unilateral flow. Now, we talked earlier about presentation layer. We have the, I didn't know I left these animations up. We have the MVC, MVP, MVVM. Now, even when you have your software architecture, it's still very important that each part or each layer should also be very well planned. So it's not like we have some onion architecture for the whole software stack, and we can just leave the presentation layer to be a mess. No, not really. Because these layers still communicate with the other aspects of the program. And as well, if we're following the clean code principles, these layers are supposed to as well represent the solid principles that clean code actually embodies. So, like using the pattern with Android, we could see that we have the view which talks to the view model, and hence the repo, which would be which the view model will communicate with, or we would have our use cases which the view model will talk to, and the use cases then talk to the repository. And here we have an example. Sorry. That's bad timing. So here we have an example of an app, but just the presentation layer. We have the dashboard, we have the feature X and Y, then we have the dashboard's view model, then we have the use cases on the domain layer, then the repositories on the data layer. So if we remember from our previous slide, we can remember how these things were able to show the data flow moving from presentation, domain, and data. And this is kind of like a data flow diagram of how these things function. We have the view talks to the view model, which then actually the eyes here are interfaces, which talks to an interface of the use case, which moves down to the repository and the data sources. Or the use case also has access to the entities, which, and the entities are actually our data itself, or our data the representation of our actual data. Then we have the domain layer, which holds the entities and the use cases. Then our data layer, which just basically holds our cache, our local database, remote databases, just where we feed data from to feed the rest of the app. In case I'm going too fast, just let me know. I would slow down a little and explain if you have any questions. Now, we have a rule of thumb for our use cases, which is every use case should do a particular thing, a single thing. I know you remember this from the solid principle when we talked about single responsibilities. So, use cases are a way for us to abstract some of the business logic. Like if you work, let me say, for an example, in a loan company, and we have a use case where we would like to get all a list of customers who are currently owing or who have not paid off their debt. We would have a use case for that, which would probably be talking to various repositories like the user repository and maybe the loan repository that would probably have like the amount, or let me say transactional repository that would probably have a list of amounts that each person is owing. And that maybe we could call it the user loan use case, would now take in those two repos and aggregate the data together and return it to the view. So all the view knows to do is just collect the finished data. The processing would be done within the use case. And with use cases are not to be transferred to different views, because a use case does one thing for this particular view. So use cases will function somewhat like our view models in a way, but the difference would be the use cases will be able to communicate with various repositories. So our use cases are the ones that would do the cleaning up of the data, while our repositories would just be returning large amounts of data to the use case, and the use case would know how to either combine the repositories to give us one entity and return to the view, or clean up the data and then return to the view. So if we go to a soft recap, we talked about the repository implementation, which would be the cache, local database, and the remote database. And the repositories are kind of like our data access. Our use cases talk to our repositories to return data that would now be passed on to the presentation layer. Now, from everything I say, if you think about it very well, you see that the presentational layer is actually just a view, or is actually the dumbest part of the whole software. It doesn't actually do anything. Its whole job is just to show. It's not supposed to make any computations. It just shows data. And this is an example of how we would actually split that. We would have how our dependencies are managed. This is like an example of a Gradle file. I'll show you this very soon within the project. All right, so let me move over to one of our sample projects. So I have this app here. I built it some time back just as a test for clean architecture. It's called Rick and Morty. It's available on my GitHub. I'll share the link. You could also check it out. So what we are going to do here is we're going to walk through this project. Then you could actually see how we could actually use this clean architecture in our work. Now, the front end part of this project is actually built off MVVM. So like earlier in the slide, you saw that the presentational architectural patterns are just part of the overall software pattern. So while we're showing this, if you have any questions or a part of the code you don't really get, just let me know. I'll try to explain it. Now, first things first, with when we want to try to apply clean architecture, one thing we like doing is we try to split up our app into various modules. Now, this is not the only way you could actually split up your app into different modules, but the kind of pattern I'm using here is a layered pattern where the data actually flows linearly from the presentation domain data and down. We have other types of patterns, which would be like we spoke earlier, the microservices pattern. I think there's a Google app, I think the IO schedule app or the Played app. It uses that microservices pattern where every feature is its own module. So that's also another way to structure your code or your project. You can actually structure it by modules. Now each of these are different modules, but in those other apps like Played, each of these are different features. Then those features now embody this separation of concern between presentation, domain, and data. But like for me, I prefer this layered pattern because it's a lot easier to get into. So first of all, like you would have your app, your app module, which actually takes in, you can ignore these other parts. Let me just try and make this a little bit bigger. Sorry, let me just increase the size. Okay. So we could ignore the other dependencies up here. The main thing what we would like to look at is these three. These three are the three separate modules, which are our data, domain, and presentation modules. And the app module itself contains all these three because it's like the gateway into the application. So let's start with the domain layer itself. Sorry, so admit. Okay. All right. So I think trying to increase the size of this. Yeah. So in our domain layer, this Multi application, we're going to start off with our entities. Like these are actually still trying to increase the size. No, it's not okay. There we go. Yeah. Okay. So in any software you're going to write or app, the main place we start from our entity is how we represent the data. And knowing Rick and Morty is a cartoon. So we have our character. We have our character entity or our character data class, which represents the ID, name, status, species. Like in Rick and Morty, you have different species like aliens, all those things. Gender, the image, and the image representation in base 64. So we won't go much into this. It's just a data class, then also another one. So the part I want us to really look at is our repository. Our repository here within the domain module is actually just a set of interfaces. Expand this. Yeah, just a set of interfaces that kind of control how this data will be accessed. Like here we have the character repository, which has a function to get characters. It has another function to load cache data from the local storage of the device. It has a function to save image. Now, as you can see, this is an interface, and it's actually not, there are no details here. So we have a remote data source as well. Is also another interface that talks about how we are going to get these characters. So we'll have a data source that would implement this and fill out the details of how these characters would be gotten. Currently, we wouldn't know where the character data is coming from, but the data source itself that will implement the details will be the one to fill that in. So anybody that's going to build off of this doesn't need to bother themselves about how is this data coming. All they need to know is they have a contract with a character remote data source, and this data would come irrespective of how it comes. They don't need to know that. For them, they just know they have a binding contract, and that contract will be fulfilled. Then we have a local data source as well, which is still the same thing. A binding contract that lets the consumer know that this data can come and you don't need to worry about the details. So we spoke about use cases earlier. So here are some use cases. Like I said, the use cases just do a single thing. We can't have one use case doing more than one thing. It would actually already break the clean architecture itself. So here we have the get characters use case, and as you can see, it feeds off the character repository, but it feeds off the interface of the character repository, not the details. So the get character use case does not know what's going to bring in the details of this. And we actually use a dependency injection. As you can see, I use a Dagger to inject dependencies. So it knows that just calling the get characters interface method, it's going to return a list of characters. It doesn't need to know how those characters are going to come. All it knows is it has a binding contract to the character repository, and this data is going to be returned. If we check our other interfaces, we can see that all of them follow the same pattern. They all have a binding contract, and they get their data. You can see that each use case actually just uses one method from the repository. Like we might have a use case that might need to aggregate some more repository. That would happen, but the point is the use case itself will just return something specific to the view. Then we could just show this use case as well, which is the upload local image use case, which is for saving images. All right, so this is our domain layer. We've seen the use cases in the domain layer. We've seen the entities. Maybe if you have any questions here, maybe you could ask before I move over to the data layer. Anyone? Okay, let me move over to the data. Oh, okay. Let's see. Messages come up. Okay, no questions for now. All right. Okay, so okay, one more thing with our data layer, with our domain layer, it's very important that our domain layer should remain clean of framework dependencies. What I mean is, like here, our domain layer is a pure Kotlin, module. It has no framework dependencies like the Android framework or the network framework. Like it remains pure because it needs to be away from the framework so that it can actually provide those interface framework for the rest of the layers to flesh out their details. Why is this way is so, like I said earlier, we're able to swap out these implementation details. Like maybe today in our local data source, maybe on the Android phone we are using SQLite, and later on we decide to use maybe BadgerDB or RealmDB. So we don't need to now change our interface or change the consumer of the interface. We just need to change the implementation details, just swap it out and still return what the interface has specified, because like you said, the interface itself is a contract. All right, so let me close these and we'll move on to the data layer. I mean, it looks like a lot of files. Yeah, we might not go through all of them, but we'll just try to speed through it and we can reiterate. Now, one thing with separation of concerns I always like talking about is we had our character file. Let me just open it side by side. Yeah, we had this I hope it will be very visible. Yes, we had this character we have the character file, the character entity, but here we have a character's response. Why we have this, it might look like duplication, but it's actually very important because it's good for us to separate our maybe API response objects from the actual entity itself, from the actual business entity, because we wouldn't expect the business entity to change unless maybe based on business rules before it should change. But well, let's say receiving data from an API service, I would expect that we should have our own mapped out entity for that response, and we can now map out the response into the actual business entity. It actually just helps keep everything, how should I say? I won't say working, but keep everything separated, because if you are going to be using the business entity itself to receive data responses from the API, anytime the API changes a value or a field, these changes would actually affect the whole application. So it's actually very important that we separate these two. And in those separations, we will usually have something called a mapper. Now, what a mapper does is it maps a data class or a data entity from the module into a entity in the domain layer. Or as well, it could also map an entity from the domain to the presentation. So our mappers, all they do is they convert one entity into another entity of a lower level. So like the character entity mapper, what it does is it takes in a list of character entity and returns a list of character which the domain layer would now be picking up from. And we have other mappers. This maps the result, the response into a character entity. The other one maps from it maps the entity from the character entity is for our local database, and it maps that to a character. So it's very important for us to always keep these things separate. Okay, so that's for the entity part. Now we have our normal API. Yes, we might not go into this. It's just a retrofit API class. Okay, so let's look at the repository implementation. Now remember when we said the character repositories or our repositories act like a contract. So here we have our repository implementation, which binds itself to this character repository, basically saying, okay, I'm going to sign this contract and I'm going to adhere to this contract. So here you can see we actually now have the details of the interface. Here, this is where we flash out all the details. Now, like earlier, the use case doesn't know about these details. It doesn't need to, because later on, if we want to change these details, we can change them easily from here without having to affect the rest of the software. And our character repository actually feeds off the remote data source and our local data source, because like the get characters method itself, it picks a list of characters from the API and it saves those characters into our local storage, then returns those list of characters. And we wouldn't want the character repository to be responsible for these two exchanges, because our repository most times acts like a data access. It chooses where data should be accessed from, either from a remote call, from the cache, or the local database. So that's what our repository actually does. And we leave the data source to actually handle the actual implementation of how this data is received or saved. I know in most instances of repositories, we actually allow the repository to actually be like a pseudo data source as well. But it really depends. The truth is, there's really no actual good architecture. So most times it actually depends on what fits what you're building. But for here, we're actually building our data sources of those interfaces we checked off earlier. And here we can see the implementation of these interfaces. Like here, we are seeing the implementation of the local data source. For this project, I actually used the RoomDB. So we can see where when we pick our characters from our local data source for the get characters, we can see how we use the character entity mapper to change it into a list of characters. So we change it to a list of characters so that the domain layer can actually consume that, because the domain layer does not have any access to the character entity, because the data layer itself is lower than the domain layer. So the domain layer should not know about it. It shouldn't be able to access it. So we have the same here for the character remote data source. We make our API requests. Here I'm using one of my libraries to actually make this request, but we can actually swap this out for any other implementation and it wouldn't still break the contract of the remote data source, because in anything that goes in here must actually return this. If we change it like as normal, you get an error because, hey, yeah, you've broken our contract, like call your lawyers, that kind of thing, you've broken the contract. So just a recap, I'm showing you an example of how our details are fleshed out and how we consume our interfaces from the domain layer. We've seen the character remote data source and we've seen the implementation details. We've seen the local data source as well. We've seen the implementation details, and we've seen the character repository, and as well we've seen the implementation details. And we've seen that these things are actually separate from the interfaces they consume, because we're trying to separate concerns and as well obey solid principles where we are building off abstractions, not details. So you can see the character repository itself is as well building off abstractions. It consumes this interface, or it adheres to the character repository interface, and it still builds off the abstractions of the data sources, not the physical implementation of these. Now, maybe if you're not really that conversant with dependency injection, I'll just do a quick move up through the app layer. If we remember our diagram, let me try and look for it. Yeah, we can see that our framework is also external to the details of the data layer or the use cases. So that's also why I also preferred to keep everything that has to do with the dependency injection, or how these details are located within the implementations, like the character repository implementation, in a separate module called the app module. So this module here, what it actually does is it holds off framework specific data, like our own database. This is where it gets initialized. Even provides our context here. Like all these are framework specific things. Now this is our data module where we actually include each of those modules for dependency injection. Yeah, so for our retrofit, the same thing. All of these are framework specific things. So if later on we want to change our network layer, we would actually just include it here, and we wouldn't need to actually change the implementation itself within our data layer. So that's why I actually like keeping these concerns separate and having an extra module just for the framework itself. So everything is contained within its own layer and not actually to leak itself into the other parts of the layers. Also remember, clean architecture principles can also be called the onion principles, because when you look at an onion is layered. So that's what clean architecture is trying to achieve. When you peel off a layer in an onion, the other layers remain intact. So clean architecture, the clean architecture principles are trying to help our software embody such things, where taking off a layer does not actually result to the complete destruction or shutdown of your application. I think someone is trying to join. Okay, message. Cabbage layer. Yeah, so yeah, so that's it. The other parts of this is just normal dependency injection creation, where we actually manage our fragments, how we add our fragments to how we instantiate our fragments, because we are already injecting some of these dependencies, so we also have to do this for the fragments. So that's all for the app layer, or you could call it the framework layer. Now let's go into the presentation layer, or the part everybody actually sees or interacts with. Here we just have an adapter. I might not go into this. It's just a basic recycler view adapter. But let me go to the view model itself, because our slides. Okay, here we go. This timer still here. Okay, so in our presentation layer, remember we have the view model, then the communication between the repo and the use cases. So let's just show how that works here. Okay, let me close these other ones just to make it neater. All right. So here we have our main view model, and this instead builds off our use cases. Now, why we can build off our use cases here and not an interface of the use case is because our presentation layer is lower than that of the domain, so it's actually able to access this directly. So that's why this itself is not an interface. So here we just inject these use cases, and as you can see, everything is specific. We have our upload image, just calls the use case for the upload image and sends it and saves it. As well, they get characters, or they load characters, which is also the same thing. It picks up from the use case. And if we are going to look at our fragment, so our activity houses the fragment. So if we are going to look at our fragment, we can see that our fragment actually does, let me close this. Our fragment actually does absolutely no computation. All our fragment does is it receives data and it adds that data to the view. That's all our fragment does, and that's basically all your presentation layer should actually be doing. It should just present what is given to it. It should not be doing computation of let me pick this, let me convert this image into this, or let me get various data sources and combine them together, then show it. No, our presentation layer should just be that. It should just present. It's just a view. And why it's important for us to do to make our presentation layer to be as dumb as possible is, in future, if maybe your your product owner, your designer, or the person who controls the features you have to your program says, okay, we need to change how this view looks. You don't need to now start duplicating or trying to copy out computations you've done within your fragment. All you do is you go and build up a new sorry, just want to share it. So all you do is you just go up and you build up a new XML file, create a new fragment, you display whatever you need to display. And because all you're doing is you're just changing the look and feel, you don't need to now start copying out how do you call it, the logic, the computation. You just build up your look and feel, and you just hook it up back to the view model, and all your data comes in like magic. Not like magic, but all your data comes back in. You don't need to bother yourself about are we going to introduce new bugs? Will we forget this computation, or someone forgot that this flag was supposed to be a boolean, not an integer? Things like that, they don't come because your view itself does not do any computation. So you're actually as free as possible to change your views as many times as you want, and this wouldn't actually break the data flow. It wouldn't break the computation, because your view is not making computations. And as well, you can also change your implementation detail as you want, but you won't break the contract. In fact, if you don't do a good implementation of your details, you won't be able to even adhere to the contract, so you can't even move forward, because your contract says you need to return a character entity, but you're not returning a character entity, so it's not even going to compile. Not that we can still have bugs in these kinds of architecture we can, but this just helps us to make it harder for that guy that's trying to, or that lady that's trying to introduce that bug. There's always that one person that just tries their best to bring in a bug where there shouldn't be a bug. So we are just trying to make it harder for that person to bring those things in. So really, that's why it's very important for us to actually keep our presentation layer as dumb as possible, as without any implementation. In fact, the only computation, if we may call it, is adding things to our view adapters. That's it. Besides that, all the presentation layer should be doing is responding to, what is it? Responding to clicks. Responding to clicks, like here, responding to clicks, or showing errors. That's all it should be doing. Anything more than that, it does not belong there in your view. And one important thing about separation of concerns and clean architecture, or solid principles within the clean architecture, is when you build your app of abstraction, it actually makes it so easy for you to write tests. Because I know unit tests has always been something programmers always talk about, like test waste time, or rather write my code to be as good as possible so I don't need to write tests. But no, actually, when you write tests, you actually check your program if, okay, are these things correct, are my implementation details actually correct. And when you are building off abstraction, it's so much easier to write these tests. Like I'll show you an example of some of the tests I have here, and how easy it is to actually build off these things. Like, we can see that our character repository itself is what we want to test. The character repository implementation test, this is what we want to test. And because our remote and local data sources are actually interfaces, I don't need to start thinking about how do I flesh these two things out. How do I manage the dependencies within the local and remote data source? No, I can easily mock these two, and even provide mock data for them. And actually, what I'm trying to test is, will my character repository return what I want it to return? And that's what I try to verify here. See? Okay. All right. So that's what I'm actually trying to verify here, that my character repository works as it should. It should return a list of character. And does it do that? If I mock these two, would the character repository still return the list of characters? I might not run this test. You know how live coding always goes. It might have a tendency to blow up in your face. So we could try though. Hopefully it doesn't blow up, and hopefully it doesn't take too much time. Well, wait for that to run. You might now say, okay, if we're already telling our test to return this, we are still going to mock out or test our data sources. So it's not like we are going to leave them. Oh wow, it did still pass. So wow, luckily. We are still going to write tests for the data sources itself. Every interface, or every interface implementation, will always write a test for it to make sure that the implementation details remain the same. So even when we change the implementation details, our test should still pass, because the tests are actually acting as a check for us to make sure, okay, we might be adhering to the contract in theory, but are we actually returning what we're expecting to return? So that's why it's very important that every implementation detail, we actually write tests for them. So here we can see that in the character repository, we're mocking our remote and local data source, but we still go ahead to actually test the implementation of that. So the test actually covers everything. And here we do test that we have our mock data and make sure we actually get what is expected. Then we assert not null or whatever you want to assert. And as well, even in the domain layer as well, you also have to write tests for your use cases as well. It's very, 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 very important. because yes, your data layer could be returning the correct things, but your use cases, you might maybe have forgotten something, or you know how these things go. Maybe you got distracted, and so it's very important that when these details are changing as well, you have your test to second guess you to make sure these things are actually sticking to that. So just to go quickly over, okay, before we go over these things again, um, an important thing I don't think I touched on is this separation in the domain layer itself. As you can see in the domain layer, we have things specific to it, like the Kotlin, the test, the coroutines are used, but we can't see anything about app data or the presentation layer here. This is where we declare our dependencies. But in our presentation layer, you can see that the domain layer itself is a dependency to it, and as well in the data layer, this is the Gradle file. You can see the domain layer as well. It's also a dependency to it. So if you remember the onion itself, you can see that the domain layer should not know anything about these other guys, and the domain layer can actually live separate from these other guys, from the app, from the data and the presentation. And if you look at the plugin sections up here, you see that our domain layer is actually a pure library, a pure Kotlin library, although we are using the Java library plugin, but it's a pure Kotlin library without external dependencies between language specific dependencies. Unlike our presentation layer, which has to have a bit of framework things like the Android library, the Kotlin extensions. Also, one more thing, right? So another thing is when you're separating your app into these various dependencies, you'll notice that usually you would see something like this up here, Android application. But because our modules are basically like micro libraries, what we're actually using up here is the Android library. So in other words, you could actually ship this whole presentation layer as a .aar file and even send it off to another place, to another app. In fact, you could actually even build this presentation layer in its own project and actually include the AR file that will be generated from the Gradle build and include it into the main project itself. So each of these modules could actually even live in their own projects. So that's another beauty about this separation of concerns. Each module could actually just live on its own, truth be told, because they are actually libraries. The only application here is the app application, and what it just does is it just incorporates these three libraries into it, and it builds off the APK or the dynamic bundle, whichever one. So it's also a very interesting thing to actually look at how each of these things is actually just a library. So it will show you that you can actually build these things even outside of the project. It's actually really good. So that's almost about it about the separation of concerns. If I'm going to dive a bit more into this, based on like if we're going to talk about a bit about solid principles, I would also say one thing is, let's start with the view. It's very important for us that in the view, this is just like a slight recap. We keep it as dumb as possible. As we said, the view should be the most stupid part of your app. It should not do any computation. All it should do is it should just show data. As you can see here, all it does is it just displays data. Just set everything to the text view, just display data. And as well, also I know definitely everybody uses get strings, so no magic strings. Yeah. Then also maybe I could just go into this adapter as well. Most times this might be a little off, but most times when we build our recycler views, we like to convolute adapters a little. I think it's very important that we try to keep our adapters as lean as possible and actually build up the concept of view models, view holders. And this helps our adapters to actually be specific in the sense that we actually see what the adapter is doing, and the view holder actually controls what the particular view that's being shown on the screen is supposed to do. Like here, the view holder is separate from the adapter, and it actually handles everything that should be done, like the click listener, setting the view itself. Then the adapter can just be specific. Like when you start writing when you are writing adapters that incorporate 2, 3, 4 different types of view holders or heterogeneous views, the adapters can actually get quite bulky, and according to solid principles, the adapters now no longer are doing what they're supposed to do. Instead, they're acting as a container for view holders, which shouldn't be so. The adapter itself should just be, this is a contract of the adapter. It shouldn't be a container of view holders where most times you see people here, they put different view holders. They put different view holders down here, which shouldn't be so, because now the adapter class is already breaking the single responsibility, which is, it should just be an adapter class. The view holder should have its own class where it handles itself. And here the contract says just return a view holder, and that's where you can now return your different view holders. So just had to touch on that really quickly. So that's a base recap of the representation layer. Also, here we have we talked about mappers. Like I said, the mappers just map an entity from one layer to the other layer. Usually they map an entity from a higher level layer to a lower level layer, and this one just maps from the character domain, to our character UI, which is actually what's finally used within the view screens. Why we did this is because here our domain layer is devoid of the Android framework, and most times we would actually want to pass in our UI objects. Like when you're trying to move from one fragment to another, or from one activity to another, you would want to parcel the object within a bundle. And we can't do that with a pure Java or Kotlin layer, which is the domain layer. So most times we would actually do this within the presentation layer, have a UI object that we can actually easily parcelize and include them in our bundles when we are moving from one activity to another, or when we are saving it to our saved instance state in case of an application being removed from memory and being brought back. So it's just another way to make our things safer. Then we'll do a recap of the domain layer. As we said, the domain layer is the kernel of the software or the application. It houses the business logic in the form of entities and repository interfaces or repository contracts, as we have here. It holds these entities, an embodiment of the business logic or the business data, and the repositories, which are just contracts that should be fulfilled. And if anything, our domain layer should rarely ever change unless there's a business decision, like the CEO says, oh, okay, you know what, we can't get characters anymore, we should get episodes, things like that. That's when the business interfaces actually need to change. And even in most situations, we'll create a new interface and build off that, and we can now remove everything that has to do with the previous contracts. And our use cases live within the domain layer. Most times you might say, okay, so there's also this argument most times that we say our use cases most times act like proxy or request forwarders when they are not doing much but just forwarding the request. But here we now think about consistency over inconsistency. Even though it's just the one line, I think we should favor consistency of having a use case. It makes it easier than having our view model just talk directly with repositories itself. And that's a quick recap about the domain layer. Then the data layer, as we said, is where we build off the details of these things. So just using the character local data, so as an example, here we put our details. Oh, I think I didn't check on the database. Here we have the database as well. How we build of the details of the database. So in this end, we can still switch all this out, maybe for realm, and all we would need to do in our character local data source is include the realm here, and it should still fulfill each of these contracts. So the data layer is basically the details or the implementations of the system. That's what our data layer is. And as a pseudo, you could also have a class for your error handling, which would be also within the data layer. The errors are basically API errors, be inside the data layer. Well, that's really all about it for the walkthrough on the project. This particular project is on GitHub in case you want to have a look at it as well. I have a project template here, which is basically a starter template to help start with this separation of concerns. Everything here is built off dummy. It's all empty, so you can quickly modify everything as you wish. It's just dummy implementations of everything, empty implementation, so you can quickly if you want to actually start with this sort of separation of concerns based on modules, you could as well get this demo project. It's also on GitHub. I'll share the link as well. Everything is already created. You can just fill out the details based on what you are building. You can modify these or do copy and paste and use it as an example to just build off till you get used to it. So everything is just empty implementations, and the dagger is already set up, but you just include what you need to include. But there are examples everywhere within the project. Everything is set up, but the examples everywhere. Although the retrofit is okay, but you can switch that out if you don't use retrofit. Then as well as for the activities and the fragment, it's all being set up. So this other one is called personality. It's a demo template. I did that template just to help people who are trying to get into this sort of separation. So I'm just trying to go through the parts to show you that everything is a demo and it's actually ready to use. If you run it, it's just going to run and show you an empty screen. So this is the demo repository. Everything is just empty. As well here, then the Gradle files. Just basic things, nothing out of the ordinary, but just everything to get you started on this. I will share the link. Maybe while I can drop the links here. I'll just see it. So you check this. This is the project we walked through. It's called Rikamoti API sample. Has some details for you. Yeah. So I'll drop that link here in the chat. Or I could also email these links later to everyone. Then the sample as well is here. Let me just get the link. I'll still email these links, but I'll drop them in the chat as well. Here it is. And it's a template, so you could actually just come and click use template, and it would generate the template for you, and you can it will just copy all that and create that template for you. So if you want to do that, you can just click on use template. I added it as a template. I'll copy that and put here. Yeah, so that added two. The first one is actually the Rikamoti sample, yeah, that uses the Rikamoti API to kind of flesh out this whole clean architecture thing. Then the other one is just a dummy implementation for anybody to build off of. Everything is empty and you can just move through that. Okay, so I think the final part is questions and answers. Anything you don't understand, anything you'd like to know, you could just ask them and we'll treat. You say nothing like perfect code, run it. So any questions? While we wait, I could be running this sample. Oh, also, I'll just have a little thank you for to Chizoba. We worked on this project, this Rick and Morty project together. He conducted the code reviews. So if you check the GitHub, you see all his comments, quite a few of them. He's an avid code reviewer. Yeah. So just shout out to Chizoba. So I know a couple of people joined late, so in case there's something you don't really understand, I'll share a link to the slides as well. I'll share the slide. I think I'll just group all of that in an email after this, so everybody can have this. Well, them later is starting up. It's just to see how the project works. So, or you have any contributions? If not questions, we're all ears. Okay, so I guess no questions then. All right. Um, oh shit, I opened this browser. So even with the Android Studio 4.0, it seems it still takes time for our emulators to load up. Yeah. So that's basically the app. I think the API key should still be working quite well. No, somebody is not displaying. Okay, go back to that. All right. So also we have I don't know for we have Chizoba here who would like kindly want to invite us to GDG Lagos. I think I'm just going to give the floor to him to speak on that. Yeah. So Chizoba. right, thank you very much. So if there are no more questions or contributions, then I think we can call it a day or an evening. It's evening here. Okay. All right. So thanks a lot, guys, for being here and attending. I just hope everything was was cool. All right. Appreciation, guys. And the links are up there. I'll still email the links. I'll email the slides as well. And yeah. All right then. Bye, guys.